Hello everyone and welcome back to Health Horizon with Pushpa. Today we are diving into an essential content that is disinfection byproduct or DBP in our drinking water, and the title is Non-Targeted Analysis of Natural Product in Source Water. Now moving on, we'll go through all these headings. Firstly, talking on introduction, as we know, drinking water disinfection is recognized as a major public health achievement of the 20th century, as it has greatly reduced the spread of waterborne disease. However, the disinfection process involves chemical disinfectant reacting with dissolved organic matter in the source water, resulting in the formation of DBPs that potentially pose health risks to humans. Epidemiological studies have reported that long-term consumption of chlorinated drinking water is associated with increased risk of bladder cancer, colorectal cancer, and poor reproductive outcome like miscarriage and birth defects. Although over 700 DBPs have been identified in drinking water, mass balance analysis of organic chlorine in drinking water reveals that the identified DBP account for less than 30% of total organic chlorine in the water. This indicates that a large number of unknown DBP needs to be identified. And the major precursor of regulated DBP is humic substances. Humic acid may degrade and transform into phenolic acid, which exacerbates the complexity of dissolved organic matter in source water and severely interferes with the structural analysis of DBPs. So, mass spectrometry, due to its high sensitivity and resolutions and rapid analysis speed, it is widely used in the identification and quantification of DBPs. We use two types of analysis. Firstly, we'll talk on targeted analysis. This helps to predict DBP based on known reactions between disinfectants and dissolved organic matter. It helps to pinpoint exact structures and reactivity sites. Second is non-targeted analysis, an unbiased approach that helps to look for any and all pollutants present in the sample. This helps uncover previously unknown DBPs. Now, talking on our hypothesis, natural product in source water like tannic acid, food byproducts, and secondary metabolites such as alkaloids might be contributing to DBP formation. The problem is that we often don't have a comprehensive understanding of these compounds. That's why we propose combining non-targeted analysis with global natural product social molecular networking, and this approach helps us predict unknown DBPs based on reactive sites of natural products. We use two powerful techniques. Firstly, talking on high resolution mass spectrometry. This helps to detect thousands of compounds with precision, and triple quadruple mass spectrometry helps to detect DBP at extremely low level. These chemometric tools and advanced software also play a major role in analyzing the massive data sets produced. This analytical scheme forms the backbone of our identification process, combining both targeted and non-targeted studies. To enhance our results, we use machine learning and artificial intelligence to detect patterns, trends, and improve compound identification. And the development of new algorithm and software will make the entire process faster and more accurate. Now we are at the end, and you can say that non-targeted analysis is a game changer. It enables a more comprehensive understanding of the natural product in source water and the DBP they might form. This is critical for maintaining both water quality and ecosystem health. Thank you for watching. If you found this video informative, don't forget to like, share and subscribe for more informative content like this. Bye bye.